Hi everyone, my name is Tina and I'm the head of chassis and integration as well as the Women in Engineering representative of Hyperloop Manchester. Today we are celebrating women in engineering through our panel discussion with our two lovely panelists, Mavi Figueres and ana.ballestar. Mavi is the founder and president of Graphene CR based in the United States, which through a partnership with Proton Powder produces graphene powders. Her passion for nature and the environment has helped her in her journey to found GCR, and she believes that through this technology, we can help heal our planet. We also have ana.ballestar with us here today. Ana holds a PhD in material science and is currently the CTO of Graphene Green Tech in Spain. She has more than 4 years of experience in the emerging industry of novel 2D materials, becoming an expert on graphene and graphene-related technologies. A big welcome to you both, and thank you for taking the time to join us here today. So to start us off, Mavi, could you perhaps tell us a little more about your role in Graphene CR and what you mean when you say graphene can help heal our planet?
Thank you, everybody. Thank you for inviting us to be in here. Graphene, I feel, is an important element. Is going to be, actually, it is already an important element for us in our planet because it's going to help heal our planet by adding graphene into as many elements as we can. It will, once those elements go back into Earth, it will help start healing Earth, the soil, start healing it from the bottom up, as well as our graphene is green, meaning our graphene comes from biomass, and therefore we use it, we take it from trees, and it's a closed circle, and therefore we don't mine it, we don't use harsh chemicals, so it is considered a green graphene. So we do have from beginning to ending a closed circle that will help heal our planet from the use from the tree, the oxygen, the carbon, the process where we implement it, where we add the graphene to all the elements to the final resting place back to Earth. So I feel that it is going to help heal our planet if we use it intelligently.
Yeah, of course, it's the circular economy sort of thinking, the sustainability that everyone's talking about right now. Thank you, Mavi. That's really interesting. And Ana, could you give us an overview of your work in Graphene Green Tech and your research?
Well, in Graphene Green Tech, we also have a strong approach to sustainability, as Mavi already mentioned. And it's already implied from the company name, right? Graphene Green Tech, graphene for green technologies. So starting from the original product, sustainable product, no chemicals, CO2 negative, meaning that we don't produce CO2, we don't emit CO2 to the environment. We keep it, so the trees keep it, and it's never put back to the environment. So that's one thing, and the other thing is that we try to approach sustainability in a way that's prolonging the lifetime of products. So, for example, if you think of the plastics, which are a huge problem currently for environment, our approach is to include graphene so that those plastic products can have a longer life. So you do not need to use more material. You don't need to produce them, which also it's use of resources. And you extend the lifetime of products. So that's one of the main things that we want to address from Graphene Green Tech. And this will also apply industries that are currently very polluting, such as construction industry. We are working hard into developing a concrete enriched graphene. And the third path that we are working on in Graphene Green Tech is the paints and coatings industry, which might be more linked to the Hyperloop project that we are now a bit here. Well, I guess we will talk later about it longer. So those are the three main branches that we are working on Graphene Green Tech. Of course, there are way more uses that graphene can have because they have other properties such as biocompatibility, antibacterial, thermal conduction. So those are other properties that we, of course, are willing to exploit. but we thought that it's better to focus a bit short and give it a pause. So yeah, as I said, those are our main three paths for graphene technologies.
I think that's very interesting because a lot of people, when they hear graphene, they're not sure exactly what it's about, but also how broad its potential applications are. People mention some applications, but it can really be taken back. And as you say, there's different projects that it can be applied to. So that's very interesting. And as you're both into a similar sort of field, how were you encouraged to get into this field? Were you inspired by someone? What was it that triggered you to want to get into this field of work?
Ana?
Okay. So I have to say that my mother always told me that ever since I was a very little child, I was always asking why is that so? How does it work? And I was never happy until I fully understood the system, how things worked. So I think I always had this curiosity of knowing how things work until I could fully understand the thing. And I was never satisfied until I do that. And I think that was one of the main motivations for me to go into science. But I also have to say that I was super lucky in school. I had a fantastic physics teacher who had really a big passion for physics, and he taught us a very, very nice way of understanding physics, which normally is not such a cool topic, but he somehow made it cool for us. And then I think he was really very important figure for me to study physics from the beginning. And actually, after I finished my PhD in Germany, I came back to Spain, and I coincidentally met him because he lives in the same neighborhood my parents do. And I actually told him, I just finished my PhD in science, and I have to say that it's partly thanks to your way of teaching physics to us as students. And I have to say that he was quite moved. And so I think it's important to have passion in what you do. And he did, and he inspired at least me. So that was one of my, if I can call it reference, I don't know, but for sure the main, very important role in my science life, so to say.
Aw, that is wonderful, Ana. It's a good story. For me, I actually come from a very, very strong line of women, very strong women in my life. My grandmother, that woman that is there in a motorcycle, she was the first lady of Costa Rica, and she was she was an American who went to Costa Rica in 1942 following a postcard, and she just ventured, got on a banana boat, and she just went to a completely strange country, and she didn't speak the language, and she literally helped lead the revolution of a country and the women's movement, giving vote to women and helping women succeed and encourage women to become more than the wife, the daughter, the secretary. She always encouraged. I was lucky enough at age 25 to be sent to come and live with my grandmother here in Alabama. And so I had the great luck of having her as my role model. And she was an amazing woman. She would, this is funny, she would charge me 5 cents every time I would put myself down. In the first month, I paid her $250. So I stopped putting myself down, and she started really pushing me. And I realized how insecure I was, and how much this woman would just so strong and push you, and don't put yourself down, and keep looking forward and keep going, and we can do it. And it's not just women, it's men, it's everybody. It's just that insecurity. So just keep going. Don't look back. Don't look back only to learn. But just keep going, look forward, move forward, do it, go for it, don't give up. And she never did. She never did. She ruled the world. She moved everywhere. She lived everywhere. She experienced the world. She was 102 last year when she died. And that woman was in perfect shape. She went to the gym every day until the last day of her life. that woman was amazing. And so to me, she was an amazing inspiration. And from her, I have aunts, sisters, uncles, my grandfather, everybody. It's a family that doesn't give up. So it's one of those, you don't have a choice, you keep going. It's just, it's beautiful. It's beautiful to just, what's next? What's going to happen? Let's do it.
Yeah, 100%. I think you both touch on really good points. I mean, Anna talking about the teacher as the role model and also family. I think you see both like the internal, but also the external people that can really help influence you to go into a certain path. It's definitely, I think, especially as women, it's definitely important to have these role models around to make sure that, you get pushed to really do as much as you can and push yourselves to your limits, not be held back by what society tells you and so on. So talking about that, as women, are there any gender specific challenges or stereotypes, barriers that you felt you had to overcome in your career, generally from your student life, maybe before until up to now?
Yes. Yeah, I was 22 when I was challenged by a whole society. I come from Costa Rica. And at 22, if you don't get married, the train is going to leave you. So I had to leave the country because I was not going to get married. So it was one of those, the society constantly pressured me. The train is going to leave me. I'm too old. And if I'm not married by 29, that's it. I'm over. I'm a spinster. And, and if you don't have children by 30, life is over. Just, oh my God, what are you going to do with life? You're not married. You don't have a man by your side. And so I had to constantly fight a society and continue fighting a society because I chose a path. I did not want to get married. I did not want to have children, by choice. I don't tell people that you should do that, just me. I didn't want to do that because I chose career. I chose a different path, careers, several, until I figured it out. So society does put a lot of pressure on you, male and female, both. And so one has to constantly the discovery of what is it that you want to do for you, not for society, not for what other people tell you. And it's very difficult when you live in a society and it's pressuring you to do one specific thing and you don't want to go that way.
Yeah, well, for me, as I mentioned, I chose to study physics, and in my colleagues, when I started, I think we were 10 girls and I don't know, 50 boys. And at the end of the studies, it got even maybe half. So we were 5 girls and 10 guys, or no, 15 guys. But we have been lucky enough to have them like as real colleagues. So I didn't feel discriminated. I felt supported by them. But it's true that we only had one female teacher all along the studies. So one teacher of all the subjects, like no matter was electrical engineering, quantum physics, chemistry, solid state physics, whatever. Every topic was given by a man, except for one woman. And I remember that we wondered what does it take to become a professor, because there was only one woman. And once you go step by step, then I went to the PhD, and then you see how the system works and how difficult it is to get there, and so on and so forth. You start realizing the reasons, no? And then it's clear that it's that we, or at least what I felt is that we have to be always perfect. That somehow you are demanded more things than maybe men have to show. And it might sound a bit typical, but I was in meetings, and maybe Mavi has the same experience that I'm about to say, that there, I don't know, you are the only woman, there are 10 men around you, you are the expert, and even though you are the expert, you are not the one who's addressed. There are questions coming up, and they never address you. They address other men, just because they are men. And it's, I mean, I also don't blame them because it's how it was so far. So it's the transition that we have all to go through, and it will help to have more women in those positions, and that's the way. And I would love to encourage women to go into science. It's an amazing world. It's really rewarding. It's super satisfying. And yeah, as we already mentioned, don't give up. No, there are of course barriers that are there, and they will be still for a while. But I hope that they slowly disappear. And we need support from men. We need support. We need support from the politicians. We need support for all society. But I think I'm very, very optimistic because I have the feeling that new generations, they are really involved into that. So I really do have hope for that.
Yeah, 100%. I think like even for me as a student, mechanical engineering student, when I tell people that I study mechanical engineering, there's some looks, there's some, oh, is that not a very male dominant career path? And it is. And I think when you go into that path, you really want to try to encourage more girls to, from the beginning, to go into it. But as you said, Anna, as well, the teachers need to encourage more girls to go into that early on, to choose these subjects, to then be able to take on more STEM-related careers. Thank you for your input. It really is very interesting. Thank you both. And going more into your field of work again, what are you currently working on in terms of graphene, and how do you think that can be related to Hyperloop in any sort of way? Are there any projects that you feel can be taken on in a society such as Hyperloop Manchester?
Anna?
Yeah, as I mentioned, I think for the Hyperloop in particular, our graphene is particularly good in conducting properties. So we have more than double conductivity that what other graphene cells are high conductive graphene. So everything that involves electrical properties. So for example, Mavi already mentioned, I think, the electrical paste that has been developed from them together with collaboration with Chile, Nanotech Chile, if I'm correct. I think those type of applications would be super useful because, as I said, our graphene is particularly good in this respect. So everything you can think of, printing electronic circuits, replacing metal connections by this electrical paste. Of course, if we go a bit further, we can think about supercapacitors, which is also something that's very needed for the Hyperloop project. I think our graphene might be very good for that. As we already mentioned, that is different from its origin because it comes from biomass. But also, if you go down to the properties, I carried out several experiments, and having a deep look on X-ray diffraction data together with Raman spectroscopy, I found out that this has turbostatic nature. And it's a bit of a word there, no? But it basically means that when you have a crystal of graphite, for example, mining graphite, you have very order planes of graphene. So they have a very specific stacking order. Whereas when you have a turbostratic one, these planes may have a different orientation. And even more, they have a bit of a larger distance between the planes. That makes the possibility of intercalating atoms between the planes way more easy. So it's way easier to intercalate atoms. And for such products like superconductors or batteries, all those who might need some intercalation or some interface, how to say, some interfacial properties there in the material or in the electrolyte or whatever you want to work on, I think our graphene has really lots of potential there. And yeah, it can be directly applied to the Hyperloop in this case.
I want everybody to know that Ana, Dr. Ballestar here, is the one who discovered that, by the way. So she is the one that discovered that our graphene is turbostratic, which is something amazing because of its possibilities with the electric conductivity. And so we have, since Ana discovered that, we have sent it to several areas in the world. And we have connected all of these different companies in South Korea, in Chile, in the United States, in Texas, in UK. We have sent our graphene to the different areas and have connected everybody with the Hyperloop Manchester group to start the process of involving all the different techniques to add them to the Hyperloop Manchester. So it's going to be a very interesting next generation of what they're going to come up with, of what's going to happen. I'm fascinated to see what you all are going to do with this Hyperloop, because the electrical conductive paste that Ana was telling us that Nanotech Chile came up with is fascinating. The possibilities of this. We don't have to have that amount of cables anymore in the pod, and therefore the weight is going to help ease the weight. I believe, I don't know, y'all are gonna have to correct me on that, but I feel that by using this paste, it's gonna help us a lot with the weight of the pod. With the paint, the electroconductive paint that we're discussing also, that we're working on, not only is going to help with the electroconductivity, as well as the extra layers of protection that we need, strength, insulation. I mean, not only for the pod here on Earth, but it might also help somewhere else with the UV protection. So it has possibilities that are beyond, that are yet to be discovered. Ana's discovery was really something magnificent. And Dr. Weaver, the inventor of our process, really was, he called me, it felt like a child with a new toy. He was so happy when he saw that. He was so proud of Ana when he saw that. He said, this is one of the best reports I've ever had and received of the studies that Ana gave him. So thank you, Ana. That was a beautiful report, and your discovery was really a very important thing for everybody. The response that we get worldwide, it's amazing from Ana's discoveries. So thank you.
Well, thank you, Mavi. You're always so nice to me. It's a pleasure to listen to you.
It's wonderful working with you. I love it.
No, it's really interesting that you guys mentioned it, because as a newly founded Hyperloop team, we are very open and we want to find novel approaches to making Hyperloop work and not just follow what has already been done. So this is the perfect chance for us to actually collaborate and integrate this technology into Hyperloop. And I'm sure the future Hyperloop Manchester will be very grateful for it. So thank you, Ana and Mavi. I appreciate that. And Mavi, are there any projects that you are working on as well in terms of graphene that can be integrated in Hyperloop? You mentioned there are 3 projects.
Yes.
We
just discovered last week, we were working on a polymer to be able to work with the Hyperloop. So we have been trying to work with Telegraph is one of our products, and we've been getting really bad results as usual. We always get bad results first. And I always tell people that my nose used to be much bigger. I hit that wall all the time, face forward. But last week, we were in a meeting with a university here in the United States, and they said, oh, the solution is very simple. And it really was something very simple that none of us saw. And so we're very excited because we did find the solution for it. So we are going to be working on polymers, and to be able to solve that problem, I immediately called England, Jay Lang in England, and I told him, okay, let's work on this, let's do it. And I have called, of course, other groups. So we are going to be working on the polymers. We also, last week at 10 o'clock, Friday night at 10 o'clock, I received a phone call that our tests with the cement base worked. For the first time in 4 years, we got very good results. And so we were very happy. So for the Hyperloop in this sense, for the pod is not gonna work, but in the future, for the tunnel, we will be working, and we will be talking about later. At this moment, for the pod, of course, we're not talking about cement and concrete. So we are working in different areas right now for the paint, polymers, and electric conductivity that are going to be something that the Hyperloop group will be able to use. And I love connecting the Hyperloop Manchester with the different groups, such as the foundation that we are forming in Costa Rica with the groups, the kids from very remote areas in Costa Rica. So we form a foundation. So we're trying to hook them up because they're working with Intel. And so Intel has already agreed to work with these kids, and we already put them together to talk to the Hyperloop. And so I find it that it's the connecting of all the different groups worldwide and just seeing what comes out. And of course, we're sending Polygraph, we're sending the paste, we're sending as much as we can send for everybody to test and to see what comes out of it. I find it fascinating just to arm you guys with as many goodies as possible, as I call it, and see what works. So I find it fascinating. I love working with people who are willing to test and play with all these materials that we can come up with.
I just wanted to point out something that I find super important, that besides the technical part, which is my expertise, I love Mavi's approach of bringing people together. You know, it's super important. The more eyes you have, the better the work will be. So, and also working with different people in different countries, that it might sound like a topic, but I work in different countries with different cultures, and everyone has a different method. And you can learn from everybody. Everybody has something to offer you, and I think it's very important to be generous in a way, to share your knowledge, to not be jealous of, if I say that, they will use it before. No, you will learn a lot, and you learn most from mistakes. So share your mistakes so that people do not do it again. They will waste time, and if you know that it doesn't work from somebody else, you will also save time. So I think that's also very important way of working.
Yeah,
not being afraid of sharing your mistakes is incredibly important. Yeah. In helping, Ana just said it exactly. If you're not ashamed of the negative results are positive no matter what. Negative results are good results. You know what not to do, then try the other way. For example, the results that we just got, the positive results. Now we can perfect it. Now we can go from there to better and better and better. But we had 4 years of negative results and trying to get to better, to positive. Now we go from there to now just better, better and better. But we've always been sharing the negative results with everybody still. So I'm not afraid of, every time I talk to any company, I tell them, okay, we did this, and this didn't work. Don't try that, but let me share with you what we did, because you probably are going to see something that we didn't see, and you're going to see it with a different perspective as what happened last week. And they said, well, did you do this? And we went, oh, no. Oh, of course we're going to go. You know, so it was something, just a little tweak. And that's how it works. That's the magic. That is the beauty of sharing, as Ana was saying. Don't be afraid. Don't be embarrassed. I mean, the more eyes, the more people. I tell people, I don't believe in competition at all. I hate it. Hate competition. I believe in cooperation. I believe in collaboration. Let's work together. It's for the benefit of everybody. It's for the benefit of all of us. Let's work together, and don't be afraid. Just don't be afraid. Put yourself out there. If it doesn't work, it doesn't work. You know, you try again, you get up, try again and try again and try again. Believe me, it's been 4 years. I've hit that wall 100 million times. You get up and try again. So just don't give up. Keep going always.
Yeah, and we have a very, very good example, no? In the development of the COVID vaccine. It was a record discovery. Like in time, it was really impressive. And what it happened is that everybody joined forces to find a solution. And I think that's one of the best examples that we can take for a very recent experience. Now, if you really join and put the best people to work into something, it works. It really works. So I think that's a very good example that we can take. Yeah.
That's brilliant. Exactly. That's brilliant. Yes. Yeah.
Yeah, I completely agree. I think the point that you made about this making it international as well. Each country has so many different types of people, different types of looks, views, and points of view, how to go about different things. So it's really important to gather everyone. And as you say, it's not always about the technical. As engineers, sometimes you think, oh, it's only about the technical, but it's not always about that. It's also about gathering the right people, making sure the projects run smoothly, and of course, it's completely right. Lastly, about Hyperloop, what do you think of Hyperloop in general? Do you believe it will be the future, or what do you think in general about it?
Well, I'm quite excited about it, I have to say. Like, I think it really can make a big difference in the way of living, like, because of course we are already living in a globalized world, because that's how it is, and because we managed to bring people together, of course, with planes. But if this can even get a step further, and then you can just commute from, I don't know, LA to California, and I think it will be like the world will be even smaller. It already feels small because you are in Sydney, and then you meet somebody coincidentally from, I don't know, just you met in Italy, and this happens already. But imagine that being even smaller. So I think it's a very good way of bringing people together, and even more the sustainability. Again, it will be a big role. No? One of the main things of Hyperloop as an advantage compared to planes is the environmental impact. So I think that's a big plus. Already thinking about the tubes with solar cells so that they can provide their own energy. I really think it's the way to go. Actually, it really, I deeply believe in it, and I know that the best people in the world are working on that. As you guys are trying to develop new ideas, and I have the feeling that every country is bringing their best people to work on that. And that brings hope for me. I have to say that I'm very excited. I'm very much looking forward to being at home in Spain and say, hey, let's have a coffee in Berlin. Then you just take a Hyperloop, one-way thing, and then you're there, have a coffee. You can even come back home for sleep. And I'm quite excited about that.
I feel that it's already happened. It's already. It's a perspective. We're already there. We just have to work it backwards, but it's already happened. So it's just that with the Hyperloop, it already got invented. We're just going backwards and simply getting to the invention, getting to it. So we're working on that backwards process right now, which is fascinating. That's the fascinating part of it. I love every part of it, the concept of it, of the tunnel, of the velocity, of the compression, of the air, of the sound, of absolutely everything. What happens if there's an earthquake, if it's underneath, if it's on top, winds, I mean, everything. It's fascinating. The entire concept, the idea of this is brilliant. I love it. And I do know that it's going to happen. We're just in the backwards process right now. So as everything in life, I feel that if you set a goal and then you work it backwards and then you get to it. So it already happened. It's just a matter of getting there now.
I think as a Hyperloop student team, it's very nice to hear people just as excited as we are. It feels the time and effort that we put in it's not going to waste. It's definitely a project that we're very excited about. So thank you for supporting it, and thank you for the help in coming up with novel approaches to Hyperloop. So we really appreciate that. And as we're coming to the end of our time together, is there one advice you would give to encourage more women to get involved in Hyperloop, or any STEM-related societies, what would that advice be?
Never give up. That's what I tell people in general, in everything. Never give up. Never, never, never give up. You do have to look back simply to learn, but don't give up. And I do know and I understand that a blow is a blow. Take a day, breathe, analyze the situation, but get up the next day and keep going. Just keep going.
Yeah, I would say follow your passion, whatever passion you have. If it is math, it's math. If it is engineering, it's engineering. If you really love it and feel that's the thing to do it no matter what society thinks, no matter what the roles are out there. If it's really your passion, you will enjoy it. It will make you happy. And that's most important.
All right, great. Thank you so much to you both. And we really appreciate the time and the enthusiasm as well in our Hyperloop project in general. And we're really hoping we can host more events in the future with you to discuss the potentials of graphene in our Hyperloop project. And if anyone has any further questions, we will share Mavi and Anna's emails if they're okay with it. So you can ask your questions directly to them. So thank you all very much for attending our talk.
Thank you.
Thank you, everybody.